Good morning students. Welcome again into the 12th science chemistry class. Today we have learned some formulae about the numericals based on the crystal lattice. That means if any metal there is the x gram of metal mass is given, then what is the density of that metal and what are the number of particles, how many particles are there in that x gram of the metal, and what is the how many unit cells are present into that x gram of metal, and again we have to calculate the volume of the total unit cells present into that x gram of the metal. Now pay attention on a blackboard. Here we have to calculate the number of particles and unit cells. Both we have to calculate number of particles and unit cells in the given numerical in x gram of metallic crystal. Then which formula are used for these unit cell to calculate the number of unit cell as well as number of particles? Let us learn. Suppose n, small n are the number of particles present per unit cell. That means in one unit cell, suppose there are the n number of particles and A cube is the volume of the unit cell. The unit cell may be simple cubic unit cell, or it may be BCC, body centered cubic, or it may be hexagonal cubic packing, that is the FCC. That is given in the numerical. Now suppose rho is the density and capital M is the molar mass of the metal and x gram is the given mass of that metal. Then we know that density rho is equal to mass divided by volume. Now here mass of that metal, that is the mass present in the unit cell, that is the mass of that particles present in that unit cell. We know that. So mass means number of particles in unit cell, and volume is the volume of the unit cell. Now if we know that in the molar mass, that is the M, capital M, in the molar mass there are the how many particles? There are the Avogadro's number of particles, that are 6.022 into 10 raised to 23 particles are present in the molar mass of any metal, and therefore we do not know the number of particles in that unit cell. So if that is the molar mass contain any number of particles, therefore how many number of particles are given into the given mass can be calculated as, that is number of particles in unit cell into capital M molar mass divided by Avogadro's number. And in this way the density can be calculated by using this formula, that is the number of particles in unit cell divided by volume of the unit cell, A cube, into molar mass divided by Avogadro's number. Now this is the formula to calculate the density of the given metal. How we can calculate the density of the given metal? That is number of particles in unit cell divided by volume of the unit cell into molar mass divided by Avogadro's number. Now if we want to calculate the molar mass of the given metal and if density is given, then the formula becomes this molar mass M is equal to rho into Na into A cube divided by this N, because M is to this side, so this divided parameters comes here, rho into A cube into Na divided by small n. Now this is the formula to calculate the molar mass of the given metal if density is known, the volume of unit cell is known, Avogadro number Na is the Avogadro number, that is 6.022 into 10 raised to 23. And if the number of particles, if we know which type of unit cell is there, then we can calculate the molar mass also of that metal. Now let us calculate the number of particles in x gram of metal, because we have to calculate the number of particles in x gram and number of unit cell in x gram. So first calculate the number of particles in x gram of metal, from which formula this can be calculated. Let us learn. Now the molar mass capital M contains Na particles. We know that any given element have the molar mass M, and that molar mass of that each element's molar mass always contain which, how many particles into that? Avogadro's number of particles. This is we learn into the 11th standard. That is molar mass correspond to the Avogadro's number of particles, or Avogadro's the mass of the Avogadro's number of particles is the molar mass of that element. So molar mass M contains Na particles. Now how many mass is given to us? X gram. So x gram of metal contains how many particles? X into Na divided by molar mass M. And therefore these are the particles that are x into Na divided by M. That is, x is the weight in gram of that metal, Na is the Avogadro's number, and M is the molar mass. Now these x into Na divided by M particles are present into the x gram of the metal. Now if we do not know the molar mass, but if we know the density and the volume of the unit cell, then if we substitute this molar mass, this value of the molar mass here, then we obtain, on substitution of the molar mass M, we obtain that x into Na divided by this term. So here number of particles in x gram, this number of particles in x gram can be calculated if we know the density by the formula x into Na, and substitute this value of this molar mass here. So rho into A cube into Na divided by small a. Now I substitute this value in place of the molar mass. So what is there? Now this Avogadro number get cancelled here. It get discard. What is remaining? Now this x, this is denominator, goes to the numerator, and x divided by, x into n divided by rho into A cube. What is remain only? X into n divided by rho into A cube. Now these are the number of particles present into the x gram of the metal, because we know that Avogadro's number of particles are present into the M, molar mass of the metal. So in the x gram, how many particles are there in the x gram? The number of particles are x into n. N is the number of particles in 1 unit cell. So x into n divided by rho into A cube. Now this is the formula to calculate the number of particles in x gram of the metal. By which formula we can calculate the number of particles in x gram of metal? By the formula x into n divided by rho into A cube. Now this is the formula. Now let us calculate the number of unit cell present into the x gram, and then calculate what is the volume of the total, that is the metal which is present into the x gram. Now calculate the number of unit cells in x gram of the metal. Let us see by which formula. Now again pay attention to calculate the number of unit cells present into the x gram of metal, which formula we have to use. So the number of unit cells in x gram of metal is calculated as, we know that n particles correspond to 1 unit cell, because in the 1 unit cell there are the n number of particles. So in the given mass, that is the x gram of the metal, how many unit cells are present is calculated as n particles correspond to 1 unit cell. Then we have these number of particles in the x gram. Just we calculate that the number of particles in the x gram is given as x into n divided by rho into a cube. So these particles which are present into the x gram of the metal, xn divided by rho a cube, corresponds to how many unit cells? We can obtain this by the cross multiplication. Now this xn divided by rho a into 1 divided by n. So xn divided by rho a into 1 divided by n. By the cross multiplication we obtain this n particle correspond to 1 unit cell. Then these number of particles correspond to this xn divided by rho a cube into 1 divided by n, that is the cross multiplication. So here n and n get cancelled here. So how many unit cells are there now? Therefore the number of unit cells present in x gram is given as x divided by rho into a cube. Now this is the formula to calculate the number of unit cells present into the x gram of the metal is x divided by density into volume of the unit cell, that is x divided by rho into a cube. So if we want to calculate the particles in the given mass of the metal, we use this formula, mass of the metal divided by density of the metal into volume of the unit cell. Now how many number of unit cells in V volume of the metal? If they in the numericals, if they given us the volume of the metal is given, then how many unit cells are present into that volume? If instead of the mass, that is x gram, they given us the volume, then how we can calculate the number of unit cell? Just divide the volume by the volume of 1 unit cell. We know the volume of 1 unit cell, that is a cube. So number of unit cells are obtained as volume of the given metal divided by volume of 1 unit cell, and this given us the number of unit cells in the given volume. Now all these are the different, that is the formulae we learned, that is number of particles are calculated by xn divided by rho into a cube. The number of unit cells are calculated by the formula x divided by rho into a cube. And if we want to calculate the number of unit cell present into the V volume, which is given volume of the metal, then it is calculated by using the formula V divided by A cube. Now let us learn now the numerical based on all these formulae. Now pay attention students again on a blackboard. Now such type of numericals or problems are always asked into the board examination. Now we first learn the problem number 1.5. Niobium, that is the metal, niobium forms BCC structure, that is the body center cubic unit cells are present into the niobium metal. So niobium forms BCC structure. The density of niobium is 8.55 gram per centimeter cube is given, rho, that is 8.55 gram per centimeter cube, that is the density of niobium. And the length of the unit cell age, that is the A, the value of A is given, is 330.6 picometer. We know that 1 picometer is equal to 10 raised to minus 12 meter, or 1 picometer is equal to 10 raised to minus 10 centimeter, because 100 centimeter is equal to 1 meter. Now how many atoms and unit cells are present in 0.5 gram of niobium? That means X, that is X is given, that is 0.5 gram, that is the mass of the metal is given. 0.5 gram. So how many unit cells and how many particle? Atom means particles, because in the metal there are the atoms, that is the particle. So how many number of particles we have to calculate the n also? That is n is present into the BCC always 2. But we want to calculate here the how many particles are present in 0.5 gram of the niobium and how many unit cells are there present into the 0.5 gram of niobium. Now this is the our numerical. If you understand very well what are given parameters and which parameters we have to calculate into the given problem, then by reading very consciously this problem or any problem, we can easily solve that problem. Now the solution. So first we want to calculate the how many atoms, that is the particles, are present in 0.5 gram of the given metal. So number of atoms in x gram niobium, that means we know the formula of x gram. So the number of particles in x gram of niobium is given by the formula. We just learned that formula, xn divided by rho into aq. Now these are the number of particles in x gram. But we want to calculate the number of particles in 0.5 gram. So here x is equal to 0.5 gram. N is equal to 2. Why? Because it is the BCC structure, body centered unit cell. We know that in body centered unit cell there are the two particles. One is at the center of the unit cell and at the 8th corner there is the 1 divided by 8 part, that means totally 1 particle becomes. So 1 plus 1, that is the 2 particles into the BCC structure. Again the density is given rho 8.55 gram per centimeter cube. This density is given. And they also given us the edge length A, that is the 330.6 picometer. But all things are into the centimeters. So convert this into the centimeter. Here 330.6 into 10 raised to minus 12 meter, because 1 picometer is equal to 10 raised to minus 12. So 336.6 picometer is equal to 330.6 into 10 raised to minus 12 meter. Convert this into the centimeter by multiplying the 100 to this, because 100 centimeter is equal to 1 meter. So this becomes 330.6 into 10 raised to minus 10 centimeter. On multiplying this by 100, now 100 means 10 raised to 2, and we obtain as 3.30.6 into 10 raised to minus 10. Minus 12 minus 2, this becomes 10 raised to minus 10 centimeter. But we have to convert this 330.6 into 10 raised to minus 10 centimeter in the value as 3.306. Now this point comes here, that means this increases by 2 and this becomes 10 raised to minus 8 centimeter, because this point, that is the original point, come here and therefore 10 raised to minus 8 centimeter will be formed. Now this is the value of the edge length. We take in the chemistry, the value is always we have to take that is after the one number, that is 3.306 into 10 raised to minus 8 centimeter. Now substitute all this value in this formula to calculate the number of atoms in 0.5 gram of niobium. So number of atoms, that is the particles in 0.5 gram of niobium, is given as is equal to this x means 0.5 gram, n, that is the 2 particles in the 1 unit cell, divided by this is the density rho 8.55 gram per centimeter cube into edge length cube, that is the volume of the unit cell, 3.306 into 10 raised to 8 centimeters cube. Now this 10 raised to minus 3 centimeter cube and this 10 raised to centimeter cube, this centimeter per cube and centimeter cube gets cancelled. Now what is remaining? This gram unit and this gram unit also get cancelled, and we know that the number of particles do not have any unit, so all the unit get cancelled here, and what is remaining? This is remaining 0.5 into 2 divided by 8.55 1.55 into 3.306 into 10 raised to minus 8 bracket cube. Now all these things are removed. Now this, if we calculate this, you can calculate via the logarithmic table. Now this become minus 8 into 3 minus 24, and if you see the logs of all these, and by adding the log of 0.5 and 2, and again on adding the log of 8.55 and 3 times the log of, here we have to add the 3 times log of 3.306, and then subtract the that is the this numerator logarithm from the denominator, and then by subtracting this new that is the denominator logarithm from the numerator, you obtain the value that is 3.25 into 10 raised to 21 atoms or particles are present into the 0.5 gram of the niobium metal. Now let us calculate the number of unit cells. So the formula for calculating the number of unit cell in the x gram is given as x divided by rho into a cube. Just we see that formula, x divided by rho into a cube. So again substitute 0.5 gram, that is the x gram, and 8.55 gram per centimeter cube, and the cube of the edge length. Now here also the unit gets cancelled because the number of unit cells also do not have any unit, and if you calculate in this way, this also the value comes is the 1.62 into 10 raised to 21 unit cells are present. That is 1.62 into 10 raised to 21 unit cells are present into 0.5 gram of the niobium metal, and 3.25 into 10 raised to 21 atoms are present into the 0.5 gram of the niobium metal. So student, if you understand this numerical very well, and again the formulae we already learned about this, that is the number of unit cells present in the x gram, number of particles present in x gram, then you like, subscribe and share this video to the other students, and also tell them to subscribe and share this video and like this video. Thank you very much for watching this video. You are always success into the examination. Best of luck.